I spent my childhood on the shore of Buzzards Bay in Massachusetts, where I learned to appreciate the synchronicity of geometry and nature. Now I live in Burlington and study civil engineering at the University of Vermont. I spend most of my time tinkering in Vody Hall, UVM's Deer Engineering building. I've been working on designing and creating an energy-efficient engineered composite with high performance in both strength and fracture resistance. My work is inspired by the natural forms of bamboo, an amazing plant, and I'm mimicking its microstructure to optimize the fiber matrix of my composite. In the fabrication of my material, I'm using unidirectional carbon fibers to give strength and epoxy as a bonding agent. Carbon composites are valued for their high strength-to-weight ratio and are used widely in aerospace and civil engineering and as top-of-the-line sports equipment. My composite, once perfected, will be implemented as blades for a vertical axis wind turbine that some of my mechanical engineering classmates are developing. Carbon fiber fabrication requires a large amount of energy, which leads to high material cost and an impact on the environment, both of which we as engineers try to minimize. A cross-section of the wall of a hollow segment of bamboo shows the gradation of fibers, the darker shapes, contained within the lighter tissue material. The ratio of structural fibers to tissue decreases from the stronger exterior surface moving inward. We call this pattern a functionally graded fiber matrix, and it is the source of bamboo's truly remarkable strength. To reduce the number of carbon fibers in my design, I studied and replicated the fiber arrangement seen in the bamboo cross-section. By concentrating the majority of the fibers in the portion of the material undergoing the greatest stress, we increase the strength, stiffness, and fracture resistance of the engineered composite. I am grateful to my patient mentor, Dr. Tan, for holding my work to high standards throughout the process. He just has an extremely infectious excitement about learning. I remember at the beginning, when we were just sitting in his office going through the what-ifs for this project, brainstorming on the whiteboard, and an idea would really start to unfold. You could just see the excitement shining in his eyes. There were no limits then. Any idea I presented was valid. We weren't hindered by the way things are typically done. That seems to be the first step in research, especially in engineering, which is so creative. To kill the notion of doing things a certain way and start fresh. To find a way to accomplish whatever it is you're trying to do more efficiently. And of course, we see the most efficient, sometimes perfectly efficient, systems and structural forms in nature. There is no better source of inspiration.